Many A-level maths students failed to score any marks at all on this IAL maths question. A large number of students left part B completely blank. Do you think that you could score full marks? Let's find out. It says, Figure 2 shows a sketch of the curve with equation y equals f of x, where f of x is the graph of cos of 2x. Between x is 0 and k, it says the point Q, that's here, and the point R, that's here, with coordinates k0, lie on the curve and are shown in the figure. So notice that the x-coordinate of R is the upper limit of the domain, the set of allowable inputs for x we have here. Part A says state the coordinates, so x and y, not just the x or the y, both of them, of the point Q, and find the value of k. So the graph that we have is in the cosine x family. You should know what the cosine x graph looks like. That starts on the y-axis at 1, and then something interesting happens every 90 degrees. So at 90, you should know it's 0. At 180, it's -1. At 270, 0. 360, it's back to 1, and so on. This graph repeats itself every 360 degrees. That's what we call the period of this graph. But we've got the graph of cos of 2x, not just cos x, cos 2x. How are the two graphs related? Well, if we call f of x cos x, we could think of cos of 2x being f of 2x. How does that help us to make sense of how the graphs are related? Well, you should know that f of 2x is a graph transformation of f of x. In fact, it's a stretch of f of x in the x direction of scale factor 1/2. So, in other words, we're multiplying all of the x coordinates by 1/2, or equivalently, we're dividing all of the x coordinates by 2. So as we go from f of x, that's cos x, to f of 2x, that's cos of 2x, as we go from a point xy on this curve to a new coordinate, well, we'd be dividing the x coordinate by 2, but leaving the y coordinate unchanged. Let's have a think about what's going to happen to some key points on our original cosine x graph. What about this point 0, 1? Well, if we divide the x coordinate by 2, it's still going to be 0, and the y coordinate 1 remains unaffected. So in fact, this coordinate doesn't change, it stays at 0, 1. What about this coordinate at 90, 0? Well, we need to divide the x coordinate 90 by 2 to get 45. The y coordinate 0 remains unchanged. So this point, which was at 90, 0, goes to 45, 0. And what about this point at 180 minus 1 on the cosine x graph? Well, that's going to become our point Q when we transform it. So if we half the x coordinate, 180, we get 90. The y coordinate is still going to be -1. So this is going to be our point Q, 90 minus 1. And what about the point R here? Well, be careful, that's not 360, that's in fact 450 on the cosine graph. It's a bit beyond one period. Where would the point 450, 0 go to? Well, if we half 450, we get 225. How could you do this quickly in an exam? Well, you should know that this point on the cosine x graph would normally be at 180 minus 1. But we know that we need to half the x coordinate here. So that would become 90 minus 1. So that's our coordinate of Q for 2 marks. And what about this point? Well, you should know that on the cosine x graph, that would normally be at 450, 0. But on our graph, we need to half the 450 to get 225. And that is the value of k, the x coordinate of R, as we see here. So k equals 225 is the third mark for part A. Part B says, given that there are exactly 2 solutions to this equation, cos 2x equals p, in the region between 0 and 225 that we worked out earlier, k, find the range of possible values for p. Notice that it's implying that there's a range of possible values in plural. Not just one value of p, we're looking for an interval, a range of possible values here. We can think of solving this equation as finding the intersection between 2 graphs. The graph of cos of 2x, well, that's the graph that we've been given in the question here, and y equals p. What does that look like? That's a horizontal line with y-intercept p. So the y-intercept of this line, y equals p, depends on what the value of p is. If p is very negative, then our line would be somewhere down here. And is the line intersecting with the curve? No. So we'd have no solutions to this equation. If we increase the value of p, well, up to a point we still have no solutions, but as soon as we reach p equals -1, we see that the graph intercepts exactly once, just touching the curve. It's a tangent to the curve. So below -1 we have 0 solutions. At -1 we in fact have 1 solution. What happens if we increase the value of p further? Well, we see that if we increase it further, at this stage we have 2 solutions. And if we keep increasing the value of p, we still have 2 up until this point here. When p equals 0, we in fact now have 1, 2, 3 solutions. So between 0 and -1, In this interval, we have 2 solutions, but when p equals 0, we have 3. And in fact, if we increase p further, we still have 3 solutions, because we have 3 points of intersection in this interval given. But as soon as we reach p equals 1, we must take care with this, then we're back to having 2 solutions. But if we increase the value of p further, then we have no solutions above here. Remember what we were looking for? We were looking for exactly 2 solutions. So that's going to happen in 2 scenarios. If p is between 0 and -1, but not including those values, because otherwise we'd have 1 or 3 solutions, if it's strictly between them, or if p equals 1. So how do we write this down using inequality notation? We say that p is between -1 and 0 using strict inequalities, not inclusive inequalities. That would be wrong. And we also need to put that p equals 1 is also another solution. Do you think that you would have scored full marks in that question? Let me know in the comments.